Okay, all right. Now to the second part of my contribution to this event. I will give you a quick overview of something that is a bit more complex, I would say, than the topics that we had previously on the space partnership. But of course, space partnership is very interesting and key also, especially for the competitiveness of our stakeholders. But this one is rather, let's say, in the direction of creating something new that we don't have yet established. So we are talking about the capability to act in space. Everybody knows access to space. Everybody knows use of space on Earth, like Earth observation, SATCOM, navigation, etc. So we are quite familiar with all of that. But the Europe needs a capability that we call act in space, and this is what we implemented now in Work Program 25 in form of a pilot mission. It's something bigger, and the main domain of act in space is called in-space operation and services. For those of you that are not familiar with this, so what do we mean? Well, we mean everything that is about servicing other satellites in space. So really approaching other satellites with a servicer spacecraft, for example, doing inspections, doing upgrades, repairs, etc. So this is what we are talking about when we are talking about act in space, really acting in space. Servicing, assembly, manufacturing, logistics, debris removal, these are the main areas that we tackle with in-space operation services. Of course, there are many more in the future, in particular, like recycling, that will come probably, and others. This activity or this area, act in space, is for us very strategic because it tackles political narratives and drivers. And those are, for us, resilience, sustainability, competitiveness, and of course, non-dependence. So as you can see, and ISOS tackles everything. It's very important for all these areas. This is why this is for us a strategic area. What we implement in Horizon Europe, and before I go to the topics from the work program, I give you a brief introduction about the ambition and what we would like to achieve. So, but first of all, what we implement in Horizon Europe to Work Program 25 is the pilot mission, and this is a visualization of the concept of this pilot mission, basically. It is made of 4 components. It is basically that we present a kind of small service infrastructure. Service infrastructure that provides services to assets in space. It is composed of a servicing component that is doing the actual service to other assets. It is composed of a host that will offer resupply for servicer spacecraft and also offers opportunities for IOD experiments on the platform. It's a kind of robotic platform, for example. This is the main idea of the host, and the logistic component that provides resupply to the host. So meaning fuel that then will be distributed to the servicer, and setups basically that are small packages, and this is a 4th component, if you want to say so, small composable and exchangeable modules that can provide a functionality to a platform. Like the USB stick provides a storage of files. You plug in the computer, your computer has a possibility to have an external storage for files. Is a similar concept. This pilot mission should be implemented as of Work Program 25 now with this call. This concept as a whole is unique worldwide at the moment. It offers opportunities for public and private actors to step in via plugins. And all this is possible starting from the pilot. Of course, looking now, what is the ambition? One next step, what is the next big thing, so to say? Of course, after a pilot, hopefully successful, and we reach it, we think about to evolve it towards really a service infrastructure for our EU and member states assets, meaning, of course, it will not stay in LEO only. We have to address other orbits like LEO, MEO, GEO. So it will increase. And this could be potentially a new flagship for us We don't know. Of course, this is something we aim at, and hopefully it will fly. Again, another step forward. What is the purpose? To really create the in-space economy. We have a lot of space economy. When we talk about space economy, everybody knows downstream applications. This is well known and is very good, and we need them. But there's a lot of more that we can really make use of in space. So creating services in space will offer us a complete new level playing field for services in space on the long run. And this is what we would like to start with. Just this is that you have the big picture here, what we would like to achieve only with the small step of a pilot mission now, starting from Horizon Europe 25. Coming back now to the calls. This is here on this slide, you see a table, basically a summary of all the ISOS related topics that we implement. You see here we have the 4 components. 21 topic for the servicing component, 22 topic for the host component, 23 for the logistic component, 24 for the startups component. And then we have a so-called CSA, coordination and support action. I will say a word on this later, but this small action, so to say, should be coordinating later all the 4 components and projects from the 4 components, so that in the end we have a target-oriented mission preparation activity. I will not go through all the figures and numbers here in this table, but just to say, of course, the budget that we expect here for the different components is quite different for the components. This has also to do with the fact that we know that there are certain, let's say, maturation levels existing already in Europe for dedicated key technologies needed for these components. So meaning we are not starting from scratch here. And this is why also the budget is a bit different. Good. Now, a bit more deep dive into the topics in short only, because as I said, one can take hours and hours discussing this topic, because it's also very complex. So 21 topic focus on the servicing component. Basically, here the objective is the finalization of the detailed design of this component, featuring also robotic capabilities. So it's clearly that we would like to have here a servicer design with a robotic capability on board. Then there's a specific outcome, of course, that also this component should analyze and consider, develop use cases for servicing real assets. So not only kind of dummy assets, but really thinking about a real use case. For example, could be an end of Copernicus satellite at the end of life. This is just an example. The second component, the host component, should also be prepared up to detailed design of the platform. The host component should be able to provide resupply to docked servicing spacecraft. It should host IOD, IOV experiments via the SATAPS modules on the platform, and should also be equipped with robotic manipulation and refueling capabilities. Refueling, of course, because it needs to refuel the servicing spacecraft. Just another word on the enhanced opportunities for IOD, IOV. Everybody, I think you're quite aware of the EU IOD, IOV initiative. This pilot mission, especially with the host component, that should offer possibilities for long-term IOD, IOV experiments on board the platform, would complement this IOD, IOV program on the long run. The idea here is really to have a platform, and everybody knows the International Space Station with the Kibo platform from Japan. If you could imagine such a host is a flying platform where a manipulator can manage these SATAPS boxes that includes the experiments on board of the platform. So like this, you can imagine and visualize in front of your inside your mind a bit, like we are thinking that the host could play a role here to generate opportunities for IoT or AV. So, logistic component. This is, as I said, this is also this component, of course, up to detailed design, must be prepared in this activity. And the purpose is mainly to bring fuel and setups from basically the launcher upper stage to the host. The last component, the setups component, is also here. We expect the detailed design at the end of the projects, of course. As I said, these are composable, exchangeable modules, different shape. They can have different shapes, but they will be plugged and played to a platform or to each other via a so-called USI, so Universal Service Interface, and it's like a USB in space. This is what we call USI. And this project and these projects are expected also to contribute with the designs of the setups to a so-called European catalog of setups. And one of the designs, and here's especially this is requested, should then made for or designed for hosting experiments inside the box. The CSI, one word to this. The CSI will be the coordinating project for all the components to bring them together to support the overall coordination and to do the overall coordination for the detailed design, for this mission preparation, and ensure the interoperability and compatibility between the mission components. This is very important, and especially this part, that all the components that are developed in individual projects must fit together. This is the main task of the CSA. Of course, there are some other tasks, as you can see here. I will not go through everything, but just to mention this, this CSA, and when you look at the work program, it is a kind of identified beneficiaries action only. That means here this project will be formed, the consortium will be formed by the coordinators of the components projects that we have. Nevertheless, there might, and we think it is useful, and this is why we established it, there is a mechanism foreseen, which we called Key Technology and Service Provider Group, where this coordinator of the other projects that form the CSA will have to include key stakeholder, basically from the projects, from the other projects, that will be will support the CSA work in principle. And this is very important for us that this is considered, so that not only the coordinators are forming the CSA, but they have to make use of the key stakeholders that are relevant for the other components. Good. Some, this is more generic aspects that they have all in common, all the components and the topics, basically. This is an extract from the work program. I will not go into detail with all of this, but just let me mention one aspect, or one or two aspects. The first aspect is, of course, the proposals are expected to consider the use of existing technologies or building blocks from various programs, not only from EU-funded programs, but also can be ESA, national funds, etc. And this is important because, as we said, we do not want to start from scratch. We want to put things in place very quickly with this mission. Second thing is maybe the last aspect that I would like to address here from this slide is that the consortium have to already foresee in the end that the availability of the results from the projects are there for the next mission phases, meaning for the next MFF. We cannot do a design here that is not that we are not able to continue with in terms of implementation next MFF. So this must be ensured and foreseen already by all the projects. So this is in quick the first part of this presentation, but I have a second part. So here, this page, this is a link to a website with updates on the mission, but also on the next important actions for the mission. One thing to the mission guidance document, and by the way, on this page, you also find the mission guidance document that provides more and detailed information on what we would like to achieve and what must be considered by the applicants that write a proposal. There you have the mission objectives inside, the boundary conditions and high-level requirements. And the proposals must address this and consider this. This is very important. One word here, this document was prepared together with our member states, and EA countries, and this was a huge exercise that we went through with the member states and EA countries since last summer, and we are happy that this was a successful exercise, and also this is a good lessons learned for us, maybe also for other areas later. I will not go through everything, but just to mention one or two of the main objectives of this ISOS 4I mission we call. ISOS 4I means in-space operation services for infrastructure. So one thing is with this pilot mission really to end this phase where we do not roll out the active space capacity for the EU. So meaning we want to do this to roll out the capacity for the EU and for our member states basically to be able to act in space. Then what is important to demonstrate a minimum of certain ISOS use cases, just also to, let's say, to relax a bit the situation, this chicken egg problem, that we need a technology demonstration that such things work on one side. On the other side, we need also to prepare the assets for being serviced. So, and here we start with the servicing provision side, really to showcase that things work, that giving ideas what services are important on the short, mid, and long term. This is what we want to demonstrate. There are many other aspects. I will not go through them now, but you have them on the slide. As I said before, this topic is strategic for us, and here you see the main basically policy drivers for this mission from our side. Of course, sustainability is key. Maintenance, repair services, etc. is very important for us. Prevent debris, so eco-design, keyword modularity here is one aspect that is very important, for example. Not on the slide, but it is basically also part of sustainability. Competitiveness, of course, preparing assets for being more adaptive. Mission adaptivity is, for example, a keyword, but also really introducing new business fields with modularity, with a complete new ecosystem like the setups, for example, can offer new business opportunities. This is important for us. Safety, of course. Debris removal, active debris removal might be an area that is very, very important in this context. Resilience, if you are able to inspect your assets, you do upgrades, you modernize them, you do refueling, life extension, etc. You contribute to the resilience of the space infrastructure. And this is how we see these strategic topics. Of course, there are other drivers, not go through everything, just to mention some of them here that are specific to this mission. EU acting as an anchor customer. Well, if you prepare your own assets for being serviced and there's a service infrastructure in place, why not to use it? So on the long run, this could be the case. If we are able to prepare on our side Copernicus, IRIS², the Galileo satellites with dedicated interfaces, and in the same time, via this pilot mission, we could promote and demonstrate successfully that services are working, then this is the right way, I think. And this is something that we also set for this as a specific, this is why we set it as a specific driver for this mission. or of course strengthening the EU strategic autonomy. But as I said, I will not go through everything, just for completeness. This is maybe the most important part. What do we want to demonstrate with this mission? Basically, we have two scenarios, A and B. Both of them must be completed so that the complete mission, ISOS for I, is accomplished. So meaning we have to address A and B with a proposal. And of course, not with a proposal, with a mission preparation, sorry for that, but the proposal have to address, of course, the components, and they are part of A and B. And so let's go through A. So for this mission, we have here in A is a kind of sequenced demonstration of a logical, let's say, logistic, but also servicing chain involving all the components. So starting from a logistic operation where the logistic component delivers goods to the host, so cargo, setups, etc. So it's a delivery action, so a logistic action. The host itself takes the goods that are delivered, so the cargo basically on the platform, demonstrates the assembly of setups to a functional unit, which then demonstrates the assemblability of basically satellites in space, but very small scale, of course, made of setups. So it can do a robotic activity on the platform, like assembly testbed, manufacturing testbed, etc. At the same time, it should also demonstrate an IOD, IOV experiment hosting. This is the host maneuver, and also refuel basically a docked servicer. It's not written on the slides, but this is also mentioned in the guidance document. And then the last element here is a servicing operation where the servicer takes a setup from the host, flies to a client, upgrades the client with the setups, and like this demonstrates a kind of maintenance upgrade service to a client. The B part, scenario B, is focusing on a servicing to a non-prepared client, meaning there's no interfaces where you can plug and play setups on. So it will demonstrate other types of services like inspection, AOCS takeover, relocation, etc. So this is the B scenario. This is a scheme how the CSA basically, as you can see here in the lower part, will then coordinate all the activities from the various components. And the CSA is in close exchange with a so-called pilot mission advisory group, which is formed of Commission plus member states and EEA countries. The Commission then, ourselves, we will then have a close exchange also with ESA on this part and other areas. The last two slides, just mentioning other calls that are currently open, may be interesting for you, is this call from European Innovation Council from Work Program 25. It's still ongoing and it's open until October. So it's a topic also for ISOS. So it's called Innovative In-Space Servicing Operations, Space-Based Robotics and Technologies for Resilient EU Space Infrastructure. We have 50 million placed there. The EIC work program accelerator challenge is dedicated, of course, to startups and SMEs mainly that focus especially in this area. So take a look. And also, of course, developments that you do there, of course, also can be used in the mission if they are really fitting very well with regards to the schedule and all the content that we are asking. The second topic is the one in defense that we have placed here in the EDF call. It's the 13OS. So it's also ISOS, basically, if you want to say so, but ISOS for defense. And the colleagues have focused on not in space in general, but more focused on orbit operations. This is why it's called on-orbit operations and services. Also here, the focus is, or not also, but here the focus is more on the ConOps for defense. So it could be also interesting for some of you. It's also still open. I have to admit that I don't know the exact deadline, but we know it is October this year. So it's still open, so there's a chance to apply. With that, I stop here, and thank you for your attention.
Sorry, I'm Alberto Alonso from ENI Space. So as setups are basically payloads that can be integrated using a common interface, like can a company participate as partner on several proposals, given that this is my payload that will be a setup on different proposals?
Sure, you need just to convince the other partners. I mean, this is not a problem. Of course, you can be in different consortia. This is not a problem, but this is then depends on your ability to convince the other colleagues. This is not a problem, no.
Yeah, we have another question from Maria Jose. So.
Hello, thank you very much, Daniel, for your presentation. I'm Maria Jose Montilla from Spanish Space Agency, and I'm managing SABIC's incubators. And I want to know, what do you think is the better opportunity of these topics that you have presented for SMEs, for companies that are starting in European projects? What do you think will be a good opportunity for them?
So you mean with regards to which component is the most promising for them to be part of, right? This is what you would like to see. So, okay, I would say definitely startup. This is a personal view, but I would say as a smaller, medium companies, especially maybe also startups could be the startups component, but also the logistic component, definitely. These are the first two components that I would think are very promising for these areas. But this does not mean that they should not be addressing the other two components. Maybe if especially as a startup, maybe it is very ambitious to say I'm a coordinator for the host. Could be, but I could imagine, especially startups and smaller companies, they have the very fresh ideas, I would say. So we are really looking forward for their ideas and concepts. And when they go, let's say, together with let's say legacy companies, and form a good competitive consortia for the servicing component or the host component, this would be great for us. Honestly speaking, this is a bit what we hope. Yes, it's always nice to see the legacy companies, forming consortia for the big things, but to get fresh ideas and concepts in place would be even better for us. I mean, in the end, on the long run, okay, we have to ensure two things. First of all, it has to work. What the solution has to work, meaning we have to ensure that there's a certain baseline experience around the table that make it fly. But second, we have to be competitive at global level. Yes, we demonstrated for Europe, but in the end, on the long run, once we hopefully successful have established such an infrastructure, then we meet the global competition. And then we need to be competitive. And therefore, I think we need really fresh and good ideas. Okay.
Thank you, Daniel. Just to complement what Daniel has said, only for ISOS in particular, in general, Horizon Europe is a program quite open to SMEs participation. Also, the presentation from EUSPA, from Carmen Aguilera, was talking about Cassini Initiative, which is an initiative, focused especially on entrepreneurship. But also there are certain topics that there is a sentence in those topics that it says participation of SMEs is encouraged. Whenever in the work program it says that something is encouraged, it's a recommendation but with a Q, like more a requisite, okay?